Okay, so we're going to look at some more graphical analysis. We're going to look at the second example from the graphical analysis notes. So this graph represents the function f, we're going to call it. Okay. And then it consists of 4 line segments, so that's these straight lines, and then a semicircle in the middle there. Just one thing to note, there is a horizontal tangent line right here where x is 0. So that's going to be helpful coming up in later questions. Now g is defined by this function as the integral from -1 to x f of t dt. Okay, so this says basically g of x is the area under the curve of f from -1 to any x value. So first, let's just do a little intro here. Find g of 3. So to find g of 3, we just have to plug 3 in for x. So that would look like the integral from -1 to 3 f of t dt. Now remember, integral just means you're finding the accumulation of the area on that interval. So you're trying to find the area from -1 to 3, which I believe is over here. All right, so you're going to find the area here, and then you're going to find the area here. So you have a semicircle and a right triangle. So that area is going to be 1/2 pi times the radius squared. It looks like the radius of this semicircle is 1, plus the area of this right triangle. It looks like our base there is 2, I believe. Right, 1, 2, 2, yep. And then your height, it looks like is 3 divided by 2. So we have, let's see, that ends up being 1/2 pi plus 3. So that should be the area we get under that curve, and that's what that integral tells us to find. All right, the next question relates a little bit back to the first video. On what intervals in -3 to 4? So we are looking, oops, I meant to do my eraser. So we are doing from -3 all the way over to 1, 2, 3, 4. Is the graph of g both increasing and concave down? Now remember, g of x is defined by this integral right here. So in order to figure out what's going on with g, you'll see here in a minute why I'm doing this, we're going to actually see what's happening with g prime. Now if we evaluate g prime, or the first derivative of g, you are actually taking the derivative of that integral, -1 to x f of t dt, all over dx, so the derivative of that integral. Now remember, if we have an unknown bound, right, we would basically just plug in f of -1 f of x, the antiderivative of f, and actually what this ends up being then is just f of x. So g prime of x is actually equal to f of x. So this graph right here not only is f of x, but it's also g prime of x. So what we know about increasing and concave down, well, if a function is increasing, that's where your first derivative is positive. And then concave down is where your second derivative is negative, or it's where your first derivative is decreasing. So we're looking where our g prime of x, or our graph, is positive and decreasing. So let's first look at decreasing. So this g prime of x is decreasing here and here. However, it is positive here and here. So the only intervals where we have increasing and concave down is going to be from, let's see here, -2 to -1, And let's see here, 1, 2, 3, 2, 4. And actually, there's going to be one more area because it's positive and decreasing also right here on this semicircle. So also from 0 to 1. And you need to make sure you justify. So we're going to say because g prime of x is greater than 0 and g prime of x is decreasing. So a little review from the last video. All right, so the function h is defined by, first, I'm just realizing this is a mistake. So let's fix this. So this should actually be h of x equals, bear with me for a second here. Let's see, what is it? G of x over 2x. There we go. Okay, so that should match. Now it's asking us to find h prime of 2. So in order to do that, we need to find h prime of x, which in order to do that, since it's a quotient, we're going to use the quotient rule. So low d high minus high d low all over low squared. So you should end up with that for your derivative. Now to find h prime of 2, we essentially are going to plug in 2 for x. So we get 2 times 2, which is 4, times g prime of 2, minus 2 times g of 2, all over 4 times 2 squared. So from here, what we're going to do is we need to know what g prime of 2 and what g of 2 are. So remember, this graph here is not only f of x, but we established that it's also g prime of x. So g prime of 2 is just going to be using the graph. Look for where x is 2, y value is right there. So g prime of 2 is going to equal 1.5, or it might be a little easier to keep things in terms of fractions. So 3/2. G of 2, remember, is going to be established or found using our definition for what g of x is. So g of 2 is going to equal the integral from -1 to 2 f of t dt. So essentially what we're doing is we are finding the area under this curve up here on this graph from -1 to 2. So we are going to be combining the areas of these outlined regions in red. All right, so our first region is this semicircle. So 1/2 pi times the radius squared, your radius is 1, and then add this right triangle, which is 1 by 1.5, and then divide that by 2. So g of 2, if you simplify all of that, should be pi over 2 plus, I believe that ends up being 3/4. All right, from there, let's sub those in. So h prime of 2 is 4 times g prime of 2, which is 3/2, minus 2 times g of 2, which is pi over 2 plus 3/4, all over 4 times 2 squared is 16. Then basically our task here is to simplify. So 6 minus, if we distribute the 2, we would get pi plus, what does that end up being, 3/2, all over 16. Okay, so then if we simplify this, we get 6 plus 3/2, which is going to be 12/2 plus 3, 15/2. Minus pi over 16. Now we can multiply top and bottom by 2 to cancel out that divided by 2 on the top. So we would get 15 minus 2 pi over 32. And that would represent h prime of 2 of that function. So now we are looking at part D. The function p is defined by p of x equals f of x squared plus x. Find the slope of the line tangent to the graph of p at x equals -1. So whenever you're finding the slope of a tangent line, remember you're finding the derivative. So we are going to be finding p prime of x, which is going to be the derivative of this function, f prime of x squared plus x, times, we have to apply the chain rule because we have a composite function here. So times the derivative of the inside, so times 2x plus 1. All right, then our next task was to find where x is -1. So then we do p prime of -1, plug -1 in for x. We get 1 plus -1, so f prime of 0, times -2 plus 1. So p prime of -1 is f prime of 0 times -1. Now f prime of 0 is the slope of f at 0. So remember way back we said at x equals 0, your slope is 0. There's a horizontal tangent line. So this is equal to 0 times -1, so just 0. And then finally, we are going to look at this function again, find the x value of any points of inflection for the graph of g. So remember, this graph is f of x, which is also g prime of x. So part E, find the x value of any points of inflection. So remember, points of inflection are where your second derivative changes sign. Or that also means where your first derivative changes from increasing to decreasing or vice versa. Okay, so let's take a look at that. So we have a change at x equals -2, it looks like, increasing to decreasing. We have a change from increasing to decreasing at 0. And then we have a change from decreasing to increasing at 1. Oops, we have a change from decreasing to increase here at -1 also. And then a change from increasing to decreasing here at 3. X equals 3. So points of inflection are x equals, what did we find? -2, -1, 0, 1, and 3. All right, so that should be the end of your notes for graphical analysis. Make sure you have these handy, review them, come up with any, summary that might help you as you go ahead and do the AP Classroom assignment.